This is example 2 of the logarithmic functions lab, part 2. In part 1 we found this function f of x equals negative log base 2 of x minus 2. And we got to this function by transforming f of x equals log of 2 of x. We found that there was a reflection across the x-axis, that there was a no horizontal shift, and that we had a vertical shift down 2 spaces. So in part 2, I want to determine some key information about this function, such as its domain range, whether it's increasing or decreasing, whether it has x or y intercepts and what they are, and if it has any asymptotes. So first we'll look at domain. We're going to see what we graphed last time. The function in red is the more basic function that we transformed into the black function here, which is the one we were assigned. So when we look at domain, we see that in our original we had a domain of 0 to infinity, and because we had no horizontal shift, there has been no change in our domain. We see that it's still from 0 to infinity. This is our x values. So writing that down, we have 0 to infinity. Next we'll look at range. So range is all our y values. Our original function was from negative infinity to positive infinity. This may look like a horizontal asymptote, however it's not. It's actually steadily increasing. We flipped our function over the x-axis. However, that does not change the range, because if you think about it, this will still go down into negative infinity. So the range is still negative infinity to positive infinity. So, writing that down. Negative infinity to positive infinity. We'll look at whether it's increasing or decreasing. We can see that our function in black is steadily getting more and more negative from left to right, so it is in decreasing. So it is decreasing. We look at if we have x and y intercepts. So it looks like we have an x-intercept at 0.250. However, we know that we have a vertical asymptote at 0, so we do not in fact have a y-intercept. So we only have an x-intercept at 0.250. So write it down. 250 and not anything. And we know that we have, I mentioned it already, but we have a vertical asymptote at 0, at x equals 0. In both the original and the transform function, it has not changed. So we can write that down. We have a vertical asymptote at x equals 0. So we have successfully determined all these key information about this function f of x equals negative log 2 of x minus 2. I'm going to algebraically solve for the x and y intercepts in case you do not have a graph. So first, x-intercept, if we want to solve it algebraically, we know that our x-intercept happens when y is equal to 0. So if we go to our function over here and substitute y f of x for 0, we have 0 is equal to negative log base 2 of x minus 2. And we are going to solve for x. So we're going to move this negative 2 over to the right by adding 2 on both sides. So we'll have 2 is equal to negative log 2 of x. And then we're going to multiply each side by negative 1 so that this is positive. So we'll have negative 2 is equal to positive log base of 2 of x. And then to solve this, we need to remember what logarithms mean. So logarithms, essentially, if we have log of base n of m is equal to some constant k, this is an equivalent statement to n to the k is equal to m. So because these are equivalent statements, we can rewrite this in this kind of form, this exponent form. So our n here is 2. So we have 2. Our k is this negative 2. And our m is this x. So 2 to the negative 2, we can rewrite that as 1 over 2 to the 2. This negative flips this 2 over, like that. And 2 to the 2 is 4, so we have 1/4 is equal to x, which is 0.25. So we can rewrite this as a point of 0.25, 0. Or you could write it as 1/4, 0. It doesn't matter. We notice that this is the same as what we got earlier with our graph. So now if we don't know what our graph looks like and we want to solve for our y-intercept graph algebraically, we will remember that a y-intercept happens when x is equal to 0. So going over to our function here and substituting y for f of x, we have y is equal to negative log 2, and substituting x equals 0, 0 minus 2. And we notice a problem. And that problem is this bit right here. This is not in our domain. It's not in the domain of any logarithm. And so because this is not in a domain, we know that we have no y-intercept, simply from this. If you try and plug in 0 into any logarithm like this, you'll find that it spits out error, error at you. Another way to see that this is not really in real numbers, essentially, is going back to our format of remember what logarithms mean. Remember, it means logarithm base n, m equals k, is n to the k is equal to m. And so essentially, if we have this log, and it doesn't really matter what log it is, whether it's negative, let's say we have log of base 2 of 0 is equal to c. What this means is we have 2, using this formula here, 2 to some c is equal to 0. And we can't find out what c is, because there's no possible way that anything to any exponent can be 0. If we have 2 to the 0, it equals 1. If we have 2 to the 1, it equals 2. And even if we have 2 to some fraction, it still won't equal 0. So there's nothing that c could be to possibly make 2 to its exponent of c equal to 0. And so this is not a possible statement, which is why there's no y-intercept, which is what we saw on the graph. But that's how we would know it algebraically. And so we have successfully found the key information of our function.